Hello Internet, my name is Quinn and this is Blondihacks. This is Mill Skills, a series of quick videos on getting started with your vertical mill. This is episode 5, Preparing Stock. Let's go. Wait, what do I mean by preparing stock? I mean, you can buy metal and we have all these big fancy machines over here to cut metal. That's a pretty straightforward process. Buy metal, cut metal, job done, right? Not quite. The thing is, when you buy metal, it comes in relatively inconvenient forms. It's going to be much different than the final dimensions that you want, and none of the dimensions on stock that you buy are going to be precise. Because bar stock like this is made in various ways. It's rolled, or it's extruded, or it's cast, but none of those processes result in precision dimensions. They result in relatively consistent dimensions, give or take. So from the factory, the dimensions on this stuff are going to be, plus or minus, I don't know, 10, 15 thousandths, depends on the material and the process. So it's going to be decent, but not good enough for the machinist. I mean, hey, if 10 thousandths of dimensional precision is good enough for you, you should go talk to the woodworkers. Here in the machine shop, we need to do a little better than that. And that's what the kids call throwing shade. All right, so let's say hypothetically we wanted to make something like this snazzy universal smartphone tripod mount. And it's 2 pieces of machined aluminum in an L, and they're held together with a spring-loaded mechanism, and you can clamp any old cell phone you want in there and aim it. And before you know it, you too will be a wealthy, popular YouTube star. Well, you can make YouTube videos anyway. The idea here is that we cut a chunk off of that guy that is going to be kind of close to the outer dimensions of the part that we want. So the part that we want to make is going to fit inside this chunk of aluminum. That's the idea. So how do we rough cut stock? Rough cutting stock is one of those things that YouTube machinists almost never talk about, but it's actually really important. And there are a bunch of different ways to do it. But the takeaway, if you are a beginner and you're staffing up for your own machine shop, is you need to invest in 1 or more tools to do this before you can start machining. One such tool is a cold saw, and that's what's been done here on this factory cut. And you can tell by the kind of curved lateral tool marks there. So cold saw looks very much like a miter saw, or some people call it a chop saw, that you would use in woodworking, but they have a sealed motor and a different blade, and they're designed for cutting steel and things like that. Now for aluminum, you can actually cut aluminum on woodworking tools, so you can use your regular DIY chop saw to cut this stuff, but be mindful of getting chips inside the motor. Another option is the humble hacksaw. This guy works great if your stock is relatively small that you're starting with, such as this piece of 1/8" drill rod. The other great thing about hacksaws is that the batteries are always charged and they don't require extension cords. However, if your starting stock is, say, this guy, well, the novelty of cutting that with a hacksaw is going to wear off pretty quick. So either get the apprentice to do it, or if the apprentice is also you, use something else. Now hacksaws are great, they work very well, but they are a lot of work. If only there was some way to take this conveniently sized small blade and this convenient small package and just have that blade move itself real fast. If only someone would invent that. Now, if you're of a certain age, you may remember the bad old days before the invention of small portable bandsaws. These things are a revelation. These guys come in corded and cordless versions, and all of the Technicolor tool companies sell some version of it. This happens to be the DeWalt, but hashtag not sponsored, but I do like it very much. And they all take a standard sized blade, and the blades are actually very easy to change. And you can also buy or make a table to mount this guy into and make it into a little mini vertical or horizontal bandsaw. There's lots of great kits out there to do that. So overall, these things are a fantastic investment. So this guy is a whole lot quicker and more pleasant to use than a hacksaw, but there are some jobs that are too big even for this guy. The next step up is the horizontal bandsaw, and these guys come in lots of different sizes, but this is the 4x6 size, which is very, very common among hobbyists and small shops. So the way these guys work is you clamp your stock into the vise here, and then this whole thing lifts up, and this top casting here is very, very heavy. And so you put your stock in there, and then you turn it on, and the blade runs, and the weight of this casting pushes the blade down through the stock, and then there's an off switch over here with a little tab that trips, and it shuts the machine off when the cut is complete. So these guys are very, very convenient, especially with that automatic shutoff feature, because the thing about these guys is they're not very fast. The largest stock that I've cut on this guy is this piece of 5-inch aluminum round bar, And cutting a slice off of this guy takes probably 20-25 minutes. And this is aluminum. Steel takes longer. I've also cut a 3-inch steel round bar in this guy. And it takes somewhere in that same range, maybe 15 minutes. So while it's not super fast, it is extremely convenient because you can leave it alone and go do other things while this guy is doing its thing. Another lesser known feature of these saws is that you can lift this guy all the way up into the vertical position, lock it, and then they give you this really crappy table that you can then install and use it as a makeshift vertical bandsaw. But don't run off and buy one of these thinking you'll never have to buy a proper vertical bandsaw if you do, because while in a pinch this does work, and I've used it in lots of projects, you've seen me use this configuration lots, this is very, very clunky. It does not cut very fast. It's not the safest thing in the world. This table is really poorly designed. The table warps very easily. The blade guards don't go down far enough for proper safety on a vertical bandsaw. So yeah, in a pinch, this works. And there are some types of jobs for which you really need a vertical bandsaw. The most common, like if you're cutting, say, intricate shapes out of 1/8-inch plate, something like that, a vertical bandsaw is really the only practical way to do that. So yeah, for those cases, this guy works okay. But if you are going to be doing a lot of that kind of work, you are going to want to invest in a proper full-size vertical metal cutting bandsaw. Now you might be wondering, how well do those saws really cut, especially the cheap ones from the usual suspects? The answer is, from the factory, not great. But with a little bit of tune-up, you can actually get very good performance out of them. You can get nice clean cuts, nice right angles, and I've got a blog post, which I will link to down in the description, all about tuning up these saws to make them perform like little champs. Now the reason this is a mill skills video and not a lathe skills video is because if you're working on the lathe, that's basically the end of the job for prepping stock. You cut it to length, or if it'll fit through your spindle bore, you just put the whole piece through the bore. You don't have to make any cuts at all. You make your part, you part it off, life is good. However, on the mill, we rarely have such luxury. Over on the mill, we want to get our stock pretty close to the overall outer dimensions of the part that we're making for multiple reasons. First and foremost, we have a limited working envelope, and our envelope is constrained in all 3 dimensions. And secondly, milling is honestly kind of slow, and it's certainly a lot slower than cutting the material. As I always like to say, the bandsaw is the fastest machine tool in the shop. It makes atoms of material go away quicker than any other tool. And making atoms of material go away is why we're here. So for example, if I'm making one of these L brackets out of this stock here, I'm going to want to make one more cut along this way. Because while my stock is close in dimension in every other sense, you would definitely not want to try and mill all of this extra stock away, because that would take forever, put a lot of wear on your cutters, and leave you with a lot of material in the chip tray instead of being able to use this material for something else. So on the mill, the next step before we can actually start making our part is to square up the stock. In computer graphics terms, this would be what we call making an axis-aligned bounding box of the part. We need to make all 6 sides of our stock machined, flat, square, and true, and we need to get the outer dimensions of that stock to be the outer dimensions of all of the features on the part that we're trying to make. For a really in-depth look at squaring up stock, I'm going to link you to This Old Tony's video on that. It's a fantastic detailed look at this process, but I'm going to show you the quick and dirty way to do it that's precise enough for the shenanigans that go on in my shop. First job is to choose our tooling, and that's easy because squaring up stock is just 6 facing operations. So if you watched the previous mill skills video about basic milling operations, you saw all the different ways that we can make facing cuts. So I'm going to go ahead and use my 2-inch shell mill for this operation. So I'm going to square up this little piece of scrap here. It's got bandsaw cuts on multiple sides, and there's a factory extrusion surface on that side and that side. So it's kind of generally a mess, which is a good place to start. Now, you're going to need some parallels, and I've chosen a piece here that is not going to end up as a cube because that's going to be helpful for understanding the workflow here. And that means that you're either going to need 2 sets of parallels because you're working in the short dimension and the long dimension, or you're going to need to get lucky like we did here and get 1 set of parallels that will work in both orientations. Try to do this with 1 set of parallels if you can, because as you'll see, we're going to be rotating through this part in an inconvenient way, and you'll be switching out the parallels a lot. Now you'll remember from the theory video in this series that the fixed jaw on the vise is the most important surface. This is the reference surface to the machine, and so every cut that we do needs to consider what's touching the fixed jaw and account for the fact that the cut that we make is always going to be perpendicular to the fixed jaw of the vise. The goal with squaring up stock is to find the perfect rectangle that is somewhere inside this stock while removing as little material as possible. So start by picking what's maybe the best 90-degree corner, the best two flat surfaces that you might have, whichever bandsaw cut is the least drunken. And I happen to have two factory extrusion surfaces here, so I'm going to place that surface against the fixed jaw and the other extruded surface down against the parallels. And by starting with the flattest two surfaces that we have, we can ensure that we remove as little material here as possible. We're making sure that the stock is as straight as possible relative to the theoretical perfect rectangle that is hiding inside this rough shaped stock. Before you do anything, make sure that everything is clean. A chip in there anywhere will cause something to not be sitting flat or square or true, and that'll mess you up. So at every step of the way, you got to dismantle everything and keep it clean. Now for this first pass, it's good enough to just clamp and go from here. We don't need any additional trickery, but we do want to tappy tap tap the part in. And that's not just a joke that I stole from The Simpsons and possibly AVE. The importance of that is to make sure that the stock is always seated down on our parallels. And that's because of jaw lift in vices. To illustrate jaw lift, I'm going to clamp this 1, 2, 3 block in here and keep an eye on that indicator. So you saw that guy move maybe half a thou, and this is a very square and true object, and so this is kind of the best case. So you can see even in the best case scenario, you get about half thou of jaw lift, and that's because the moving jaw, as it clamps in, naturally has a tendency to lift up slightly under the clamping force, and then that clamping force lifts the near side of the part slightly. So that's why we tap things into the vise. And you can always tell if your part needs clamping in by just touching your parallels. If your parallels are loose, that means you need to tap in your part because it's not sitting down properly in the vise. Now at this stage, your back parallel should be snug, but your front parallel probably won't be, even if you tap it in. Because nothing on here is square or flat, it's often not the case that you can get both parallels tight on the first pass, but by the time you're done, you definitely will be able to. To do our first pass, we need to touch off, and as I've said in the previous videos in this series, it's important to manage our depth of cut, and so we want to touch off on the highest part of this rough surface, which you can generally tell just by eye if you get down low like this. So I'm going to touch off over here. Now after your first pass, there's a good chance that you'll still have a low spot. It depends very much on how straight your bandsaw cut was. So just keep going back and forth until you've got a nice machined surface all the way across. You can also see here how skill with the bandsaw can save you a lot of time, because if you're good with it, you can cut fairly close to the final dimensions that you need and only have to machine off a little bit. But if you're sloppy with the bandsaw, you got to leave yourself a lot of wiggle room, and you got to do a lot more machining to get this guy squared up and to dimension. First pass done, now we can set up for the second side. So we can take our part out of the vise, and now we gotta clean everything up. Anytime you change your setup, gotta get it all clean again. And that means, yes, take out your parallels, get them clean too. These chips get in everywhere, and they're gonna mess everything up. So get it all clean. Once we've cleaned that up, we have a reference surface. So now we know that the perfect rectangle that's hiding in this material that we're after has this as one of its faces. So what we're going to do is put this now perfect face against the fixed jaw of the vise, and we're going to do another pass. And what that's going to do is give us a perfect 90-degree corner as well as two square faces. A common beginner mistake at this point would be to put that side down and face this side next, but that'll introduce a whole bunch of errors. It won't even give you really two parallel faces, because when you clamp this part in the vise, these two unmachined surfaces are doing the clamping, and they aren't square to either of these faces, and they aren't parallel to each other, so this part is going to be sitting at some wonky angle in the vise, and so you're going to end up with two very flat surfaces that probably aren't parallel to each other and definitely aren't square to anything else. So that's why we have to do it 90 degrees at a time, and that's why it's often inconvenient for your parallel setup, but that's life. That's what it takes to get some precision. But even putting this nice machined surface against the fixed jaw is actually not quite enough, because when we clamp down on this with the vise, remember that these vise jaws are very parallel, and this unmachined surface here is not parallel to the one we just machined and not square to anything. What's going to happen is these vise jaws are going to distort this part in the vise. The vise jaws are going to force these two surfaces to be some approximation of parallel, and so the part's going to end up at kind of an average location. And that's going to then mess up this surface when we machine it flat. You're going to end up with this angle back here not being 90 degrees. So how do we solve this problem? We put something round in here like a ball bearing, or this is a piece of precision ground 1/8" drill rod, and we clamp a round thing between the part and the vise jaw. And what that does is, if you remember from high school geometry, the point of intersection between a circle and a line is a single point. So that cancels out the efforts of this vise jaw to try and force the part to be parallel to this vise jaw, because we got that round thing in there that's only touching at one point, or in this case, because we have a cylinder on a plane, there's one line of contact there. Now at this point, once again, your inner parallel should be tight. Your outer parallel may or may not be, depending on how out of square this part is. And once again, touch off and machine. Okay, that's looking good. Now we can take our part out. But before we set up for the next operation, there's one more thing we have to do, and that's deburr. Because just like having chips in there is going to mess up our precision, having burrs on these corners is going to mess up our precision. So after every single operation that we do in this squaring up process, you got to deburr every edge that was affected by that machining operation. Okay, so now we have two machined sides and we have a machined corner. So now we have a reference 90-degree edge, because we know that since this surface was against the fixed jaw and this surface was machined by the spindle, and assuming the tram on our head is good, then we know that this is now 90 degrees. Now we take the reference 90-degree surface on the part and install it in the 90-degree reference edge on the machine, which is the combination of the fixed jaw and the base of the vise. And of course the parallel has just translated the base of that vise upward, and so now if we place this part in here like this, we know that this part is very square to the fixed jaw on the vise, and we can do our next pass. And once again, I'm clamping with that round bar to keep this unmachined surface here from influencing the alignment of the part on that fixed jaw. And now in principle, you should be able to get both parallels tight, because the bottom of this part is machined and this surface is machined, and those surfaces are sitting on the fixed reference surfaces of the vise. So of course the back parallel is tight. This front parallel is snug, but it's not tight, so there's drag on it. But what that means is that my angle back there is not perfectly 90 degrees, so it might be out by a few tenths, and that's enough to where both parallels might not get super tight. And after deburring once again, we now have 3 machined surfaces and 2 90-degree edges. We have a U of joy, if you will. So now we can place this guy like this in the vise, and we have machined surfaces on back, front, and bottom. And now we don't need this guy anymore, because we have 2 surfaces that we do know are parallel, and this guy will clamp and tap in properly without this little helper. So So now we have this delightful little part that is machined on 4 sides, and we know that the opposite sides here are parallel and all these edges are 90 degrees, and so now we just have these ends to deal with. So really all we have to do is clamp them in the vise any old way, because now we know all these machined surfaces are true. And you can see I've switched out to a 1/2-inch end mill here because those big shell mills don't do very well with side milling. Now we still need to tap this guy in, even though these are all machined, because again we need it sitting down on the parallels and we need it to be sitting flat this way. Otherwise, when we side mill this surface won't end up square to the top and bottom. But now this is a machined surface and we don't want to mess it up. So when you go to tap it in, either use a machinist hammer that has an end that's softer than whatever your material is, or use a shim or some kind of piece of scrap just to protect that guy from the hammer blows. And of course, make sure your parallels are flush with the vise down here and not sticking out further so you don't hit them when you go to do the side milling. And now we've got all 6 sides faced and everything is square and flat, and this part is ready to have features added to it. Now that wasn't the absolute fastest way to square up stock. You can, for example, combine those last couple of operations. If you're clever with how you position it in the vise, you can do the final facing and milling the ends at the same time, and so forth. Now you may have noticed that all of this time we never said anything about dimensions, and that was kind of intentional, but now presumably our stock is square but larger than the axis aligned bounding box of our part that is now hiding in there. To quote Michelangelo or Da Vinci, or I don't know, one of those dead guys who said that we just have to now remove everything that doesn't look like an elephant. So the next thing you'll generally do is bring everything down to the final dimension of the outermost features of the part, and then proceed from there. And again, that dimensioning process you can combine with squaring up if you're paying attention and planning ahead a little bit. At each step where you've got a machined surface down on the parallels and you're facing this one, you can not only face it, but bring it down to final dimension at the same time. You got to be a little careful doing that. It's easy to forget where you are and mess up the whole part, but that will save you a lot of time when squaring up stock. So now we're ready for layout or whatever else we might need to do to start making our part. I hope you found this useful. Thank you very much for watching, and we'll see you next time.